Hi friends, today let us see how a flow graph for n is equal to 6 looks like. So we are having a problem of getting a sample with sequence values as n is equal to 6. Surely this problem is a Composite Radix FFT problem. So we need to divide the given points. Let us divide the given point. So I'll divide n as, now there are two possibilities. I will divide it as 2.3 or I can divide n as 3.2. So for a given problem, I can have two solutions, one with 2.3 and second with 3.2. Let us consider 2.3 first. For 2.3, I will write the generalized formula as m into n1. So here, if we consider this problem, then I have m is equal to 2 and n1 is equal to 3. Similarly, if I consider this problem, then I have m equals to 3 and n1 equals to 2. In both the cases, the solution will be different. We know that m governs the number of stages. So here there will be 2 number of stages, whereas here there will be 3 number of stages. Here it governs the number of terms in each of the stage. Okay. Now let us write the generalized formula. So the generalized formula for x of k was equal to first summation n is equal to 0 to n1 minus 1 x of nm w n raised to nm k plus summation n is equal to 0 to n1 minus 1 x of nm plus 1 w n raised to nm plus 1 of k, and so on. This will turn up. The last sequence or the last term in the sequence is given as summation n goes from 0 to n1 minus 1 x of n m plus m minus 1, and lastly we have w n raised to n m plus m minus 1 into k. Okay. So now here let us consider, let us say this as my case 1 and let's say this as my case 2. So let's consider case 1 where my m is equal to 2 and n1 equals to 3. In this case my formula will be x of k, right? Now till the final value is m minus 2. So m is 2. So it will be 2 minus 1. Right? So 2 minus 1 is 1. So only this term will sustain. Right? Because I wanted to go from nm to nm plus m minus 1. So here when I put 2 minus 1, that 2 minus 1 is 1. So it will be only till this value. So I will have first stage and the second stage. So there will be only 2 stages. So I will have summation n is equal to 0 to n1 minus 1. So that I will give n1 is 3 minus 1 is 2. Correct. So x of, now m is 2 again. So 2 n w. Okay, here n value is 6. Capital N value is 6. So I will have 6 n m, that is 2 n k plus summation n goes from 0 to 2, because again 3 minus 1 x of 2 n plus 1 w n raised to 2 n plus 1 k. That's all. If you don't remember this formula, you need to understand that there will be 2 stages in this case because m value is the 2. So I will have the first value and the second value, that's all. Now for the third is for the case 2. Let us say for case 2, I will write here case 2. Let us say for case 2, where my m value is 3 and n1 value is 2, my x of k will be equal to summation n going from 0 to n1 minus 1, which is 1 minus 2 minus 1, which is 1, x of n into m, so it will be 3n w 6 raised to 3nk plus summation n going from 0 to 1, okay, x of 3n plus 1 w 6 raised to 3n plus 1 into k plus dot 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 and so on. How many values it should be? There should be only 3 stages, right? So the dot 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 satisfies one more stage is required, not many, because your m minus 1 will be 3 minus 1, which is 2. So including this, okay, 1, 2 and 3, there will be 3 total stages. So I will have summation n goes from 0 to 1, x of 3n plus 2 w 6 raised to 3n plus 2 of k. Okay, so this dot 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 is this term. There is no more other term will be coming because m minus 1 will be 2. So we will have to go up till m minus 1. So up till m minus 1 means here 3 minus 1 is 2. So I will have 3n plus 2 as the last term. So we have 3 total stages when m is 3, and we have 2 total stages when m is 2. Okay, and you see that first we write 2n, then I write 2n plus 1. The next stage will be 2n plus 2 and so on. Similar way, here that changes you can see x of k, 3n, 3n plus 1, 3n plus 2. Okay, and so on and so forth. We will be going for any value. Let us say m is equal to 4. For m is equal to 4, this value will be 4n, 4n plus 1, 4n plus 2 and 4n plus 3, because there it will be m minus 1 will be 4 minus 1, which is 3. So that will have 4 total stages. So m governs the number of stages and n1 governs each the terms in each stage. For here, for example, we will have 2 values, 0 and 1, which is n1. So here I will have 2 terms, here I will have 2 terms, and here also I will have 2 terms. Whereas in the previous case, that is case 1, n will have 0, 1, 2, that is 3 values. So I will have 3 values in this term, this stage, and 3 terms in this stage. So that is governed by n1. Okay, now let us take one case and solve it. So the flow graph of it looks very different, and to make that flow graph we need to do a lot of maths first. So let us consider case 1, where my m is equal to 2 and n1 is equal to 3, and my x of k, because of this, comes as summation n goes from 0 to n2 x of 2n w 6 raised to 2nk plus summation n going from 0 to 2 x of 2n plus 1 w 6 raised to 2n plus 1 into k. Only 2 stages. Now let us solve this. The first term or first stage does not have to be altered more. Okay, so let us write it as it is first time in the first step. We will alter this. Now this, if you see this term actually mean e raised to minus j 2 pi by 6 into 2n plus 1 into k. Now, if you see this value, we can split this value as e raised to minus j 2 pi by 6 into 2nk into e raised to minus j 2 pi by 6 into k. And we know that w 6 raised to 1 is nothing but, or 6 raised to k is nothing but e raised to minus j 2 pi by 6k. Right. So I can split this value into two sub values. So we will do that. Summation n going from 0 to 2 x of 2n plus 1 w 6 raised to, now this I can write as 2nk into w 6 raised to k. Okay, so this is just for your reference. This is just for the reference sake, for you to understand where this step is coming from. Now, we see that w 6 raised to k is an independent term with respect to n, and the summation is with respect to n alone. So I can bring this term outside of summation, and I can write it as summation n going from 0 to 2 x of 2n w 6 raised to 2k plus, let's say, summation n is equal to 0 to 2 x of 2n plus 1 w 6 raised to 2nk, the whole is multiplied by w 6 raised to k. That means it is outside, not w 6 raised to k. Okay. Now, to bring it into DFT formula, I want the n to match this n. Okay. For the matchup of this n, we will bring this 2 down. How to do that? Again, for your reference, I will show here how to do that. We take w, okay, I'll do here, w 6 raised to 2nk, right, which is equal to e raised to minus j 2 pi by 6 into 2nk. The same thing I can write as e raised to minus j 2 pi nk by 6 by 2. I am getting this 2 in the denominator of 6. This will result into e raised to minus j 2 pi nk by 3. This is nothing but w 3 raised to nk. Correct? So I started with w 6 raised to 2nk and I end up with w 3 raised to nk, which gives me the periodicity over here as 3. Okay, so to adjust that term, I did this manipulation. Now this term becomes summation n goes from 0 to 2 x of 2n w 3 raised to nk. I can replace w2nk to w3nk plus I have this w6 raised to k with me over here, and then again I have the second term, which is summation n goes from 0 to 2, okay, then I have x of 2n plus 1 into w 3 raised to nk. Okay, so we have received something different terminologies. Now let us see what these terminologies are. So for the terminologies, we need to understand what they are. So we started with x of k. We end up getting n is equal to 0 to 2 x of 2n w 3 raised to nk plus w 6 raised to k summation n going from 0 to 2 x of 2n plus 1 w 3 raised to nk. Right, that is what we have received. Now, this value is a 3-point DFT, and this value is also a 3-point DFT. That means the value inside this is 0, n will take the value 0, 1, 2. Here also n will take the value 0, 1, 2. So periodicity of this 2 DFT is 3. Whereas this K has the periodicity of 6 because we started with n is equal to 6. So your DFT will have the periodicity as 6. This is 6 point. So this K also have to be 6 point. Okay. So we are having two smaller DFTs of 3 point, and when I add them together, multiply WK 6 raised to K, I am going to get a 6 point. Okay. So how it will be? Let us see there. Okay. So I write this as x1 of K, and this I write as x2 of K. Okay. So x1 of K is equal to summation n is equal to 0 to 2 x of 2n w 3 raised to nk. Here the value of n will be going from 0, 1 and 2. Oh, sorry, k value will be going as 0, 1 and 2. So I'll write it again. The value of k will be over here 0, 1 and 2. Okay, if I open this, it will be, put the value of n, so it will, n is equal to 0, 2 multiplied by 0 is 0, so w 3 raised to 0 plus n is equal to 1. If I put x of 2 w 3 raised to k plus, then I put x is equal to n is equal to 2, it becomes 4 w 3 raised to, this becomes 4 2k, right? Okay, then this is my x1 of k, and what are the values of k? K will take as value as 0, so I am going to get x1 of 0, which is nothing but x of 0 w 3 raised to 0 plus x of 2 w 3 raised to 0 plus x of 4 w 3 raised to 0. Then I am going to get x1 of 1, which is nothing but x of 0 w 3 raised to 0, it doesn't matter because n is 0, x of 2 w 3 raised to 1 plus x of 4 w 3 raised to 2. Finally, x2 of 2 will be equal to x of 0 w 3 raised to 0 plus x of 2 w 3 raised to 2 plus x of 4 w 3 raised to 4. Agreed? So these are the 3 sets that I am going to get from x1. Similar 3 sets you are going to get from this, but you see that the number will be odd. Okay, so my x, I'll write with different color for x2k. This is not x2, this is x1, 2. It belongs to x1 of k. Similar way for x2k, let us write for x2k. So for x2k, I am going to get summation as n is equal to 0 to 2 x of 2n plus 1, okay, w 3 raised to nk, and my k is going to be 0, 1, 2 only, alone. Okay, now let us open with respect to n. So x2k will be equal to, if you put n is equal to 0, it is going to give me 1, that is x of 1, w 3 raised to 0 because n is 0 plus x of, if you put n is equal to 1, it will be 2 plus 1, that is x of 3 w 3 raised to n is 1, so it will be k plus x of n is equal to 2, and you put n is equal to 2, this will be 2 into 2 4 plus 1 5 w3 raised to 2k, because n is equal to 2. Okay. Now, if you open this up, this becomes x of 2 of 0. First value of k is 0. You get x of 1, w3 raised to 0, plus x of 3, w3 raised to 0, plus x of 5, w3 raised to 0. You will get x2 of 1, which is equal to x of 1, w3 raised to 1, plus x of 3, w3 raised to, this is 3 raised to 0, 3 raised to 1, plus x of 5, w3 raised to 6, not 6, it's 2, because we are putting the value as 1, k as 1, so if I put k as 1, it becomes 2, here it becomes 1. Then lastly, x2 of 1 is equal to x of 1, w3 raised to 0, plus x of 3, w3 raised to, I'm extremely sorry, this is x of 2, let me write it again. If I put x2 of 2, which is equal to x of 1, w3 raised to 0, plus x of 3, w3 raised to 2, plus x of 5, w3 raised to 2 into 2 becomes 4. So these are the new 3 sets. So we have this 3 sets of stage 2 and we have another 3 sets for stage 1. Let us see how both the stages looks like. So let us draw 6 parallel lines. So let us draw 6 parallel lines, because this is n is equal to 6. So let us draw 6 parallel lines. 1. Let us complete stage 1 alone. 2. 3. Then we have 4th line. 5th line. Lastly, 6th line. So now we have got our 6 parallel lines. Let us write the input. 3 lines for first stage, 3 lines for second stage. So we started with the first stage. So let us write the equations for the, let us write the first stage. In first stage, we were having x of 0, x of 2 and x of 4 together. In the second stage, we were having x of 1, then x of 3 and x of 5 together. So what I did, I combined them according to the stages that I am getting. So I got in the first stage x of 0, 2 and 4. So I combined them together, and in the second stage I got x1, x3, x5. So I combined them together. And if you notice that this is even odd segregation, we have actually done decimation in time. Now we know that from first equation, let us bring our first equation. So the first equation, if I bring into first equation, the first equation says that x1 of 0 is nothing but addition of x0, x2, x4, because w3 raised to 0 is 1. So I need to add x0, x2 and x4. We know that to add we want a node. So let us bring a node. Let us say that this node is going to give me the value of x1 of 0. So x1 of 0 is nothing but x0 plus x2 plus x4. Okay, let us bring the next value. For the next value, let us consider this as a equation. Second equation, I am going to get output as x1 of 1. So I am having x0 multiplied by 1, that is x0. Then I have x2 multiplied by w3 raised to 1 and x4 multiplied by w3 raised to 2 together added. Okay, so I will have x0, I will go here and I will, let's say, I'm going to get x1 of 1. For x1 of 1, I want x0, so I'll bring x0. This is my x0. Okay. Then x2 is coming, but x2 is coming with w 3 raised to 1. Right. And then x4 is coming from below, so x4 will be coming from here to give me x2, but x4 will be coming with w 3 raised to 2. So I am going to multiply w 3 raised to 2 to x4 and going to get added, and w 3 raised to 1 will get multiplied to x2 and then will be added with x4. Likewise, I got x1, x11. So I will now go for x2, x12, that is the final value. x12, I am going to get x0 back. So I have x0, I have x2, and then I have finally x4. So x0 without w3 raised to 0, which is 1, x2 which will be w3 raised to 2, and here lastly we will have w3 raised to 4. Okay, that is stage 1. Similarly, if you see for the odd part, it will be the same. So we will have here 3 lines coming together, here also 3 lines coming together, and here we will be getting 3 lines coming together. Okay, now this will be x2 of 0, this will be x2 of 1, and this will be x2 of 2. Okay, similar way, here it will be w3 raised to 1, w3 raised to 2, and w3 raised to 4. So this will be w3 raised to 4, this will be w3 raised to 2, okay, then this will be w3 raised to 2, so, and this will be w3 raised to 1, likewise. Okay, so this is my stage 1. But that is not the end, because we have seen in the previous formula that I want x of k. I do not want x1 of k and x2 of k. I want x of k, which is nothing but addition of both this x1 of k and x2 of k. Okay, so if I write x1 of k in this terms, let us keep this graph a bit aside and let us see what is x of k. If I write x of k, I will write x1 of k plus w6 raised to k x2 of k. Right. So if I put k is equal to 0, I am going to get x1 of 0 plus w6 raised to 0 x2 of 0. Right. Similar way, I can write x1. So it will be x1 of 1 plus w6 raised to 1 x2 of 1. Right. So on, if you write 2, then it will be with 2. But the problem arises when you put x is equal to 3. When you put x is equal to 3, I will write x1 of 3, but it's wrong. The x1 of k and x2 of k are having the value, k value goes from 0, 1, 2 as we have seen. Where to get this 3? But we know that k is periodic. So after 0, 1, 2, the next value will be again, it will be 0. So I'm going to get x of 0 plus w6 raised to, but this k is having a periodicity of 6. So it will go like 3 x2 of 0, x4 is x1 of 1 plus w6 raised to 4 x2 of 1, x5 will be x1 of 2 plus w6 raised to 5 x2 of 2. Okay, so we have seen that for calculating x of k, we are going to merge. So the first output will be x1 of 0 plus x2 of 0 multiplied by w6 raised to 0. Second will be x1 of 1 plus x2 of 1 multiplied by w6 raised to 1, and so on and so forth I am going to write. Okay, let us draw the graph based on the equation. So the first equation is x1 of, let us take some, I am going to get x1 of 0 added with x2 of 0, then I am going to get x of, so x1 of 0 let's say added with x2 of, so this is my x1 of 0 coming, from here my x2 of 0 coming, multiplied by w6 raised to 0. Now we have seen that this one is my x of 0. Now for x of 1, let's say this will be the point, x of 1, the equation stands as x of 1 will be x1 of 1 plus w6 raised to 1 into x2 of 1. So I will have x1 of 1, which is this one, and x2 of 1 I will be getting from here, and then I will be multiplying this stuff. x2 of 1 is this, and I am multiplying this guy with w6 raised to 1. Okay, then I will get x2, which is this one is like coming from here, and then x2 will be coming from here and here. This is x2. Okay, so this will give me x2 of 2, but I am going to multiply by w6 raised to 2. Okay, then x3, for x3 you need to take care. For x3 we are going to get x1 of 0 again plus w6 raised to 3 into x2 of 0. So now I am going to get values from above. Okay, and here on the x2 I am going to multiply it by w6 raised to 3. Next will be x1 will be bringing down, and then this will get multiplied by w6 raised to 4. Finally, I am going to bring down this is w6 raised to 5. Okay, so that is what you will get x3, x4 and x5. So that is Composite Radix FFT. This is we called as Radix 3 FFT, which we called as a cat cradle. Okay, this structure is called as cat's cradle structure. Okay, cat's cradle structure, which is radix 3, and this is our normal radix. So we see that there are two stages which is governed by M, and there are 3 twins in each of the stages that is governed by N. Thank you.